Hello everyone, my name is Wardatul Jannah. Along with my lecturer, D.R.S. Saputro, we are part of Department of Mathematics, Faculty of Mathematics and Natural Sciences, Universitas Sebelas Maret. Today, I want to show you our research about parameter estimation of Gaussian mixture model with expectation maximization algorithm. Outline of this presentation are introduction, material and methods, result and discussion, conclusion, and acknowledgement. The first is introduction. The Bayes theorem is often used to determine conditional probability distribution with several interacting variables. Bayesian model with complex variables require a sample Y to solve it. One of which is network. Network in Bayesian is a graphical model whose variables are interconnected or related. So for determining the probability of a problem event using the observed event and possible consequence, Bayesian network can be used. Bayesian network is a combination of a probabilistic model and a graphical model. In the graphical model, the nodes represent of random variable and the earth represent of conditional independence between variable. The Bayesian network structure described will produce a graphical model which becomes the subproblem. Modeling its Bayesian network subproblem can use Gaussian mixture model. The Gaussian mixture model is parametric density function which consists of Gaussian function component. The component of this function consists of different ways to produce a multimodal density. The Gaussian mixture model efficiently models the distribution of data observation as a weight sum of parameterized Gaussian distribution. An obvious problem in fitting the BN or Bayesian network and I-CMME or Gaussian mixture model is the approximation of the parameter given by the observation. The idea of applying maximum likelihood estimation to Gaussian mixture model started in the 1930s. Parameter estimation is estimating population characteristic using sample characteristic. The population usually has a large size. So to know its characteristic through census is very difficult. The census is also not economical in the term of time, effort, and cost. Therefore, estimation can be done by conducting a survey of sample taken at random from the population. Then the result of the sample characteristic from the survey are used to estimate the characteristic of the population. The sample used in the survey is a sample that truly represents the population. Maximum likelihood estimation. Maximum likelihood estimation is a parameter estimation of probability distribution by maximizing a likelihood function. In I-CMME, the likelihood function is in the form of an addition logarithm. So it will be difficult to maximize using numeric. So the maximum likelihood estimation is not effective for I-CMME. In the I-CMME, probability distribution more often used incomplete data. So that in this study, the estimation of I-CMME parameter is carried out by EM algorithm. The second, material and method. Material. Bayesian network is modified from Bayes' rule, which express the relationship between the opposite conditional dependencies, probabilities A with condition B and probabilities B with condition A in terms of the marginal probabilities PA and PB. This technique uses a graphical representation of the iteration application case of Bayes' rule with additional inference across some variable and some statistical relationship. Bayesian network consists of two parts. A qualitative component in the form of a directed acyclic graph or DAG, and a quantitative component in the form of conditional probabilities. Since Pn is based on the TAG model, so Pn is a pair of GP where Vg is a directed acyclic graph consisting of a set of nodes V equal alpha 1 until alpha n and directed edge set D between the variable nodes so that its node alpha V has a parent set PV equal alpha V1 until alpha Vm, and there is an acyclic potential probabilities alpha V with condition PV. The combined probability of Bayesian network are these. Gaussian mixture model. Gaussian mixture model is a parametric probability density function represented as the sum of the weight of the Gaussian probability density. The reason for choosing GMM over other are because 1. Many events or phenomena in the universe follow a Gaussian distribution. 2. Gaussian functions have a convenience of mathematical deduction. 3. An approximation of an arbitrary probability distribution with a sufficient number of combined Gaussian distribution. The Gaussian mixture model distribution with K-mixture component are these. Methods. This research is a theory-based research conducted by studying the literature from various sources that support and are relevant to the review conduct. The literature used is related to PN or Bayesian Network, GMM, and GMM parameter estimation algorithm, such as maximum likelihood and expectation maximization. The steps applied in the study are analyze the weakness of the maximum likelihood estimation on the GMM density function. 2. Correct the ML estimation using the EM algorithm. 3. Checking the convergence of the algorithm. Result and discussion. The result of the discussion include two things, namely parameter estimation of the GMM density function and the convergence of the estimates. The parameter estimation carried out in the study applies the EM algorithm. The EM algorithm published by Dempster and used to determine the ML estimation value of the combined data repeatedly, while the convergence of parameter is done to find out whether the estimation stops or continues. The parameter estimation of GMM. EM is an iterative method that tries to find the maximum likelihood estimator of the parameter theta of a parametric probability distribution. Similar to k-means clustering, it starts with a random case for the two distribution or cluster and then proceed to increase iteratively by alternating two steps, expectation and maximization. The expectation step is more difficult than the maximization step. The idea of the EM algorithm is to guess theta t for the parameter, calculate the expected value of the likelihood function, and maximize the expected result. The step of estimating parameter GMM are the one, determine probability density function of GMM. Let X is x1 until xn be a list of all observations, each of which is statistically independent of the other and taken from the distribution P x with condition theta. It is assumed that the data are incomplete so that the GMM probabilistic density function has the following as is. 2. Determine the log likelihood function of the GMM probabilistic density function. The log likelihood like this. Maximization turned out to be difficult given the logarithm of addition. The solution is the EM algorithm introduces a hidden state Y, which is defined according to the mixed component that are the sample data included in the mixed model in simplifying the maximization problem. So the GMM probabilistic density function become like in this presentation. So that the log likelihood function is described as follows, like this. Determine the parameter estimate in the M iteration. Let gamma IG is the parameter estimate in the M iteration. It is necessary to optimize the function denoted by Y with condition X, theta M, to get the value of gamma IG. So the estimate of gamma IG is written as this. Because probabilities Xi with condition Cg can be easily obtained by statistical model based on Bayes rule and equation we get this, which satisfies sigma gamma Yig equal 1. After we get the parameter estimate of iteration, we can determine the estimation parameter with EM algorithm. The step 1 is A step. Determine conditional expectation Q theta with condition theta M. With the mathematical, we can get QE theta with condition theta M like that, where C is a constant that does not depend on and thus can be omitted without affecting the M step. We can get the expectation like this. The second is M step or maximization step, estimating parameter value of theta, which satisfies sigma Yg equal 1, sigma G, Wg more than to 0, and Gr 1 until K. We can get the estimate theta like this. So we can get the estimate of weight like this. To find the estimate mu G and sigma G, we can get the optimal can be found by setting the child to 0, like this. And the covariant matrix are sigma G, we can get like this. And the last step is check convergence of EM algorithm. Check for convergence by calculating the new log likelihood like this. Repeat the expectation state if error more than delta with set. Otherwise, the algorithm ends. Moon also explained that due to the general nature of the algorithm are guaranteed convergence, the EM algorithm is a good choice to consider in many estimate problems. The conclusion is the expectation maximization algorithm is effectively used to fix the maximum likelihood estimation on the estimation of the Gaussian mixture models because this algorithm can solve log likelihood function problems that are difficult to solve numerically or computationally. In addition, The expectation maximization algorithm is also more stable numerically than other algorithms because its iteration, the log likelihood goes up. Acknowledgement. The acknowledgement this article is like this. This is the reference of this presentation. Thanks for attention in this presentation. Wassalamualaikum warahmatullahi wabarakatuh.